Slug flow is a two-phase flow phenomena which consists of a liquid and a gas. If a two-phase flow is fully stratified, the gas flows above the liquid and both flow smoothly. At higher gas velocities, waves may be introduced in the fluid, making the interface between the liquid and the gas less smooth. This is often caused by the gas moving quicker than the liquid. If a wave that is picked up by the gas fully fills the pipe, it forms a slug. The formation of these slugs therefore depends on the relative gas and liquid flow velocities. For low velocities in horizontal pipes, the flow is fully stratified, and for higher velocities, slugs may form. As you can see from the diagram on the right, there are other possible flow phenomena when two-phase flows are present in piping, but these will not be discussed in this webinar. Alternatively, slugs can be created in lines with a mixture of gas and liquid near vertical segments, where buildup of liquid and a sudden release can result in a slug flow downstream. We see here in picture 1 that liquid collects at the bend before the vertical pipe. Gas pressure builds up on the upstream side and pushes the liquid upwards into the vertical segment. At some point, the gas reaches the lowest point and blows out the liquid. Once most of the liquid has escaped, the flow and pressure are reduced, and some of the liquid falls back down. As you can imagine, this is a process that repeats itself over time. Both these types of slugs can travel at a high velocity and therefore cause impact forces on bends and tees. This may lead to vibrations or stress issues. It is therefore important to consider the effect of slug flow in lines susceptible to it. Think of condenser outlet lines, blowdown lines, and hydrocarbon production lines. By doing this in the design phase, slug-related problems may be prevented. It is not easy, however, to predict slug flow. Special two-phase flow software is required to predict the flow behavior and to obtain characteristics for the slug required for our stress analysis. So why can slug flow be a problem? This is because the slug travels through the system exerting loads on all the changes in direction. The gas in the system often travels at a high velocity, and since the gas pushes the slug through the system, the slug velocity is also high. As the slug is formed by the liquid and not the gas, the density of the slug is quite high as well. The combination of a high density and a high velocity results in high forces at direction changes due to the conservation of momentum.